Hello everyone, this is Brady. Today this is a geometry nodes modeling practice. So basically this is a live noding but with a voice. So I don't actually know how it will came out eventually, but we will see. So firstly, before I actually start, I want to explain what kind of basic thing that you can do with geometry nodes. One is to deform the mesh, like override the position. For example, I take data vertices to thousands of meters away, and this is one thing that you can potentially do. Another way is to instance. So sometimes people also use the instance to make meshes. For example, if you look at the geometry node, the splash screen, it's actually instance of Suzanne. So it looks like he's generating flawless, but it's just the instancing of Suzanne in many ways. So it's kind of a very unique way of working. But another more formal way, I think, is just to deform the mesh. And this is what we are going to do. So here we are going to noding, and I'm going to switch the geometry nodes, add a geometry nodes modifier. It does not matter what's the original shape of your primitive. You can start with a sphere or whatever, because you can also use the cube primitive inside the geometry nodes. So I don't know which one you want to start. I think either way is good. So first thing I would like to do is to put the bottom 4 vertices to the floor, so that it can make our life a little bit easier. So here what I can do, let me think, is give a attributes separate. So I'm going to take the position and x, y, z. So the more important is the z. So if I take the attribute mass, actually I need to compare, or comparison to the maximum. So z floats and override z. No, should I not override the z? Actually, let's take a new z. This is a very tricky question, because I don't really know. Do I actually write the original z or use the new z? I have no idea. This is the part which makes the geometry nodes workflow really weird, because you're passing the same thing. If you consider a normal math node, you just you input what you input is going to be what you output. But in geometry nodes attribute workflow, you just have to write things again. So bizarre. Anyway, so now I usually just move on. But if you don't know geometry nodes very well, or you cannot imagine what's going on here, you may not actually understand what actually happens. So let's just combine. So if I'm recombine everything, x, y, z, and finally override the position, you can see everything goes to floor. Okay, so this is what it happens. This is a very tricky moment, because next thing I would like to do is to enlarge the bottom part. Okay. So once we have this z, we're going to try to very interesting question. What am I going to next? Because I would like to, you either shrink the upper part or enlarge the bottom part. This is what we're trying to do. So I think it will be easier if we start with the bottom part. We have the z for the bottom part, which can be used as a mask. So, but the mask, this mask is actually the mask of 0. It's not a mask of 1, which makes it a little bit awkward. So let's firstly take the attribute field, because we want to have a number. And I think just set that auto. Let's just take a magnification, type M, and we type 1. And we're going to take the attribute mass. So let's firstly take the multiply. So if I x multiply, then I'm enlarging that. This is what happens. If I'm going to take the y, I'm enlarge that as well. I'm going to take this enlargement, link that to the magnification that we have. So let's think in this way. So I'm going to take the attribute mask, take a color rank, take a map range. Yes, we have the attribute map range. Yeah, that's fix everything. Oh, Jesus Christ. So I'm going to take the Z. I'm going to remap everything. So our Z, so now the button for corners is 0. So I'm going to remap that to 1. So the menu 1 to 1. So I'm going to remake Z. I'm going to turn the result as Z prime. Okay. Should I take the minor case or a lower case or uppercase? I have no idea. Anyway, does not really matter. So we can clamp this because it's ZP. It's whatever. Does not really matter at this moment. So once we have the prime, we're going to take the attribute mask, take the M, and then we'll take the attributes as ZP. And finally, we just the output either M or ZP. It does not really change anything. But we're going to take the attribute now. So let's take ZP. Attributes ZP. Yes. Now we're having an error. I don't know why. Oh yeah, why I have these two. Why it goes to 0? I think this is a little bit different from what we trying to do initially, but we get the results. Okay, so even if it's a little bit different from what we try to do initially, I think we get our answers. So let's move on to the next step. It's actually very simple. Next step is just to make the center part to be a little bit hollow down. This part is maybe a little bit tricky because, yeah, it's actually pretty simple though. Whatever we're trying to do previously is to basically mask out the lower portion of vertices and trying to manipulate the only lower part. Although we end up manipulating both upper and the lower part, but I think it's still in the range of control. So what we're trying to do next is to firstly, we only want to manipulate the upper part. This is already done with the previous maximum as already. So we can use the Z because the Z at the bottom is 0, but the mask on the top is 1. So this is the good part. The second part is I'm going to create a kind of spherical part so that we are going to make the dedentation kind of a hollow. Not a hollow, but yes, still kind of concave structure. If we are making a kind of concave structure, we must increase the vertices because sphere cost amount. You can also use Boolean, but I don't want to use Boolean. I think you should, even in a traditional way of modeling, I think you should use the proportional editing. Anyway, so let's subdivide. Please remember the subdivide, which makes how should I say, which actually cut this entire node tree into the frontal portion and the back portion, whatever. So here we're trying to firstly, let's get we want to measure the distance, because if we're trying to measure a sphere, we always use the distance attribute vector mass. Take the distance. Next is we're going to measure the distance from the top, I guess. So let's take a attributes combine XYZ. Let's combine with Z, and this time we call it ZD because we're going to measure the distance. So now be aware that once we combine XYZ, this ZD is becoming a vector. But when we measure the distance, it becomes a float again because I'm going to override the ZD. Sometimes you have to bear in mind about how value has been changed from node to node. So we're going to take the position, then I'm going to take the distance, take the ZD and override the ZD, vector back into float. At this moment we do not see any effect yet, but we can visualize the things easier in this case using point translate. So you can see the upper part has been affected very small, but the lower part has been drastically driven crazy. Here, this is because the distance at the center is the lowest, at the border is the highest, but this is opposite to what we want. So we still need to use either a map range or color ramp, whichever you want. Take a ZD, take a ZD. So now we have only the center part being affected, but both the upper and the lower center part. So here we already finished the spherical part. Then we need to project this center part mask to only select at the upper axis. In this case, previously as mentioned, because we have already a Z mask providing 0 and 1. So we just multiply these two masks together. Let's take the attribute vector mask. So I'm going to multiply ZD and Z. So let's take a new ZD. Does it change anything? No, it does not change anything. Why? Have I done anything wrong? No, actually it does work. That's it. Oh, it does work because it eliminates the lower part. Yes, we are successful. Again, the pointing going to that direction does not really matter, simply because we are working with ZD, which is float. Float is a single number, but when we translate, it will be replicated into 1, 1, 1, so that it goes to positive direction. But we're not going to use this point to translate anyway, so what we're really trying to do is to use this vector mask. And I'm going to use either subtract or add, whichever you want. I think there we will see the effect. And I'm going to take the position again, take the ZD and take the position back. So this is basically kind of similar effect of point translate. But here we're trying to combine this twice. And take the ZD only to affect the Z-axis, and take the ZD. So we've done. We have a KeyCap. Only the center portion has been affected. Can we shade it smooth? Yes, it can be shaded smooth. This is being finished. You can try to bevel outside the modifier. Remember to turn on the angle, and then we just try to add the subdivision surfaces, shade it smooth. Now it looks kind of much better KeyCap. Just to know that in geometry nodes you need to, where's my geometry nodes? Yes, in geometry nodes you need to be able to manipulate all this kind of amplitude of whatever. So there's different ways you can add a new mask, but you can also decrease this whiteness. Yes, this is a KeyCap. You can also change the interpolation. There is not many interpolation for a color map. I suppose there's a node. I don't know why. I remember there was node called attribute curve interpolate, but it's not 2.93. Maybe 3.0 or personal build. I don't know where does it come from. Oh, B-spline is a very good result. And you can decrease the magnitude. Oh, this is so nice. But this is just a practice. you can take all these kind of values back to the back to place so that you can manipulate them. So now this is nice. Another thing is if you try to manipulate the height, I think does not really matter where you manipulate the height. You can add the mass at whatever place. I think you just add a attribute mass and use z and multiply. Actually, I'm going to put this attribute mass right after our first attribute. Yes, I think this is a nice result. So let's take this back to the place. Okay, so we have the Z controls. We don't need to concern about this. The issue of working with color ramp here is that you do not directly have control on this stuff, which is very bad. So I do not suggest you to do this. Okay, let's use a more traditional way. I'm going to take the attribute mass and take the multiply and ZD times a value and take the ZD. So if it's 1, otherwise it just go back. So we can take this value back to place, and the rest I think it's not meaningful. Probably this is the, I'm not sure if I would like to put this color ramp to the place. It does affect the scale of all stuff. How do we actually manipulate the scale? So firstly, let's take this back to I cannot put this long stuff back to. So take this. Where's my? Oh yeah, right. It's here. So how can I actually manipulate the scale? Is that we can try to multiply the so let's take a attribute vector mass, and here we're trying to do a multiply. So I'm going to take the position vector and the p. We are not going to write the position because these or that reasons. Once we type that, where have we actually changed? Oh, this is so bad. So the top part is the something that you can change the scale without the affecting the color ramp. So the top parts, like take a combine XYZ. So we can take these two parts as 4. Take the Z. So once we have this, we can manipulate this area. I think this is good. The only thing that we really cannot manipulate is the type, but I think it does not really matter if we. I think it does not really matter because I think the bleach spline is the best method compared to others, and in the worst case, just try to use whatever method you want within the node tree. So this is just a practice. I don't think if I explain things well, because it's kind of very hard to concentrate while I'm explaining things. It takes a lot of notes. I don't think this is practically what you should really do. don't think this is anywhere meaningful to people, but this is a very good learning experience. Basically, it's about using the location as a mask. So the most important thing is you need to differentiate 0 and 1. With these two things, it's significant. It's already good enough to get a mask. There are many different ways to get a mask, but today using the maximum, where's my maximum? Oh yes, using the maximum is one of the way. There's also compare, map range, or whatever other things, clamp. But yeah, this is it. So I hope you enjoy this, whatever, and I hope to see you next time.